Welcome once again. So this is D block element session 2. So up to this we have discussed, and now we are going to discuss about the reduction potential trends in D block elements. For this, let me go for this tabular column. Look at this tabular column. What is given in the tabular column? Now, this is enthalpy of atomization. Enthalpy of atomization that we have discussed yesterday itself. And this is first ionization energy and second ionization energy. And this one is regarding the hydration enthalpy. Hydration enthalpy. And this is what I am concerned now about. So இது ஒரு மெட்டல் 2 plus stateல இருந்து 0 ஸ்டேட்டுக்கு வருது எலக்ட்ரோகெமிஸ்ட்ரி ரைட்டா 2 plus stateல இருந்து 0 ஸ்டேட்டுக்கு reduction நடக்குது. So the potential required for it is called as reduction potential. So the standard reduction potential of 3D series இங்க கொடுத்திருக்காங்க. இங்க பாருங்க the values is minus 1.63 இருந்து அப்படியே குறைஞ்சிட்டே வருது. And there is a sudden increase in manganese. Why there is a sudden jump here? Anybody can guess why there is a sudden jump here? Because of manganese is half filled, sir. Manganese is half filled, sir. Okay, va? Again, the decrease goes on, goes on, goes on. And there is a very unexpected increase in case of copper. This reflects the very least reactivity of copper பா காப்பர் வந்து ரொம்ப less reactive metal காப்பரோட reactivity ரொம்ப கம்மி அப்படிங்கறத ஈஸியா புரிஞ்சிக்க வைக்கிறது நமக்கு இந்த வேல்யூ தான்ப்பா ரிடக்ஷன் பொட்டன்ஷியல் வேல்யூல இருந்து தான் நம்ம இது ஈஸியா அண்டர்ஸ்டாண்ட் பண்ணிக்கிறோம் ஓகேவா தென் finally for zinc we know it is minus 0.76 zinc க்கு ஒன்றும் பிரச்சனையே இல்லை and I want to show you one thing these values are already given in this tabular column also பாருங்க இந்த இடத்துலயும் ஏற்கனவே அதை கொடுத்திருக்காங்க காமன் டேபுலர் காலத்துல and another point I want to highlight here this is m2 plus m reduction potential ஓகேவா and the next one is பாரு 3 plus ல இருந்து 2 plus க்கு வர்றதனுடைய வேல்யூ for scandium the values are not measured and it is not given scandium titanium vanadium chromium manganese iron cobalt nickel copper zinc நல்லா கவனி இதுல what are the things to note down sir copper க்கு exceptionally high value all the remaining are negative that means somewhat more reactive metals but only for copper the reduction potential is positive that means copper is less reactive it cannot remove copper cannot react with dilute sulfuric acid and it cannot liberate hydrogen gas. It cannot liberate hydrogen gas. Whereas zinc with very dilute sulfuric acid also will liberate hydrogen gas. This shows the reactivity of copper is very low. Copper is very low. Okay, sir. Next, there is a sudden increase here. This shows that manganese is half filled. Manganese is half filled. Though there is a large decrease in all other cases, there is a large decrease. Look at the decrease from copper to nickel. From copper to nickel, the decrease is very less. இதுக்கு ரீசன் என்ன சார் அப்படின்னாக்கா நிக்கலோட ஹைட்ரேஷன் என்தால்பி தான் இதுக்கு காரணம் நிக்கலுக்கு ரொம்ப அதிகமான ஹைட்ரேஷன் என்தால்பி இருக்கும் அதை நான் காமிக்கிறேன் டேப்ல காலத்துல காமிக்கிறேன் தென் when we go for 3 plus becoming 2 plus when we go for 3 plus becoming 2 plus இங்க பாருங்க இவங்களுக்குலாம் 3 plus சார்ஜே கிடையாது that is why there is no value given which is for 3 plus to 2 plus இவங்களுக்குலாம் 3 பிளஸே கிடையாது ஆக்சிடேஷன் ஸ்டேட் நடக்கும்போது சொல்லிட்டோம் when we taught oxidation state பாருங்க இந்த லாஸ்ட்ல இருக்கிற இவங்களுக்குலாம் 3 பிளஸ் ரொம்ப ரேர் வாய்ப்பே இல்லை அதனால 3 பிளஸ்ல இருந்து 2 பிளஸ் ரெடியூஸ் ஆகிறத பத்தி இங்க கொடுக்கல சரி நெக்ஸ்ட் பாருங்க when we go from 3 plus to 2 plus who is having the greatest value sir cobalt is having the greatest value cobalt is having the greatest value ஒரு சிமிலாரிட்டி காமிக்கிறேன் இப்போ உங்களுக்கு ரைட் என்ன சார் சிமிலாரிட்டி ஃபர்ஸ்ட் அயனைசேஷன் எனர்ஜி எங்க இருக்கு பாரு இதான் ஃபர்ஸ்ட் அயனைசேஷன் எனர்ஜி யாருக்கு இருக்கிறதுலே ஹையஸ்ட் பாருங்க ஜிங்க்குக்கு அதை விட்டுரு கடைசியா இருக்கிற ஜிங்க்குக்கு ரொம்ப ஹையஸ்ட் அதை விட்டுரு ஸ்டேபிள்ங்கிறதுனால அடுத்ததா ஜிங்க்குக்கு அடுத்தபடி யாருக்கு அதிகம் கோபால்ட்டுக்கு தான் ஜிங்க்குக்கு அடுத்ததா யாருக்கு அதிகம் கோபால்ட்டுக்கு அதை ஞாபகம் வச்சுக்கோ அதே மாதிரி 3 பிளஸ்ல இருந்து 2 பிளஸ்க்கு ரெடியூஸ் ஆகுறதும் கோபால்ட்டுக்கு தான் ரொம்ப அதிகம் அடுத்ததா மேங்கனீஸ் அடுத்ததா அயன் இந்த 3 பாயிண்டையும் கொஞ்சம் நோட் பண்ணி வை இது ரொம்பவே இம்பார்ட்டன்ட் வாட் டு யூ அண்டர்ஸ்டாண்ட் ஹியர் சார் What do you understand here? Right. Look at the values bar. What the values say? Let me start with copper, which is very special first. Sir, copper or a value, apart from we expected, it is positive, sir. Why? Because it is NCERTல கொடுத்திருக்கிற அதே வேர்ட்ஸ் எழுதுறேன். Inability of copper to liberate hydrogen gas from dilute acids. Copper is not that much reactive னு அர்த்தம். Copper is not that much reactive னு அர்த்தம். Right. But copper liberates hydrogen from nitric acid. Okay, why? Because this is a oxidizing acid. This is a oxidizing agent. That is why. Oxidizing agent. That is why. Okay. Next. அடுத்தது. The ionization energy 1 plus ionization energy 2. This value is not balanced by the hydration enthalpy of copper. That is also another important thing. பாருங்க, this is first ionization energy and this is second ionization energy. ரைட்டா? இந்த ரெண்டையும் ஆட் பண்ணீங்கன்னா ரொம்ப 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 அதிகம். When comparing this hydration enthalpy, the addition value of first and second ionization energy is very, very, very high in case of copper. In case of copper, it is very, very high. இந்த ரெண்டு ரீசன்னால தான் காப்பருக்கு பாசிட்டிவ்ல இருக்குன்றாங்க. ஸோ காப்பருக்கு பாசிட்டிவ்ல இருக்கிறதுக்கு ரெண்டு ரீசன். ஒன்னு, inability of copper to liberate hydrogen gas. And another thing, the ionization energy of copper is not balanced by the hydration enthalpy. ரைட்டா? ஓகே. அடுத்தது மற்றவங்கள பத்தி பேசுவோம். அதர்ஸ் வேல்யூஸ். ஈநாட் மேங்கனீஸ்க்கு டிஃபரெண்டா இருந்துச்சு. ஏன்னு சொன்ன சார்? ஹாஃப் ஃபில்டு, ஹைலி ஸ்டேபிள் சார், அதனால மேங்கனீஸ்க்கு டிஃபர் ஆச்சு. ஜிங்க் 2 பிளஸ் டிஃபர் ஆகுது. இங்க டிஃபர் ஆகுது பாரு. இதை விட இது கம்மியா தானே இருக்கணும். 0.25 விட the value of zinc should be lower than minus 0.25, but it is minus 0.76. Why? Because zinc is fully filled. That is why the value is showing a different trend. And in case of nickel, the value is not that much variable. Nearly the same value. Why? Because more negative hydration enthalpy. Nickel is having more negative hydration enthalpy. Clear? Yeah, please, sir. How do you know more? When comparing this, the increase is less. But for the here the increase is more. Comparatively. Okay, va? Right. அடுத்தது. Just now I told you M3 plus also becoming M2 plus. Right. When you go for this, scandium has the lowest value and zinc has the highest value. அப்படின்னு கொடுக்குறாங்க. Yeah. Because scandium 3 plus, this is 3D0 configuration, 4S0 configuration, correct appa? It will never become scandium 2 plus because since it is more stable octet inert gas configuration, the forward reaction will not happen. That is why the EMF is lowest. Whereas zinc 3 plus if it is one, it gains one electron and becomes zinc 2 plus because this is 3D10, this is 3D9. So this fellow is stable. So this reaction will happen immediately. That is why the EMF is very, very higher for zinc 3 plus to becoming 2 plus. So zinc 3 plus becoming zinc 2 plus, now it will be very, very fast. NCERT ல இருக்கிற lines இது அத்தனையுமே. சரி, அடுத்தது மேங்கனீஸ்க்கு கொஞ்சம் அதிகமா இருக்கு. எக்ஸ்பெக்ட் பண்றதை விட அயனுக்கு கம்மியா இருக்கு, வெனடியத்துக்கு கம்மியா இருக்கு. ஏன்னு கேக்குறாங்க. இருக்கு, NCERT லைன்ஸ் தான் நான் சொல்றது ஒவ்வொன்றுமே. ஏன் சார் அப்படின்னாக்கா பாரு, மேங்கனீஸ் அதிகமா இருக்கிறதுக்கு காரணம் Mn2 plus D5 half filled configuration. எப்ப கேட்டாலும் அதே சொல்லிடு. மேங்கனீஸ்க்கு அதே ரீசனை சொல்லிடலாம். அயனுக்கு சொல்லணும் பாரு, அயன் 3 plus அப்படின்னா 3D5 becoming iron 2 plus அப்படின்னா 3D6. இதுல எது ரொம்ப ஸ்டேபிள்? இவன் தான் ரொம்ப ஸ்டேபிள். தட் இஸ் வை அயன் ஹேவிங் லோயர் வேல்யூ. வை வெனடியம் இஸ் லோயர்னு கேக்குறாங்கன்னு வச்சுக்கோ. வெனடியம் 3 plus, வெனடியம் becoming வெனடியம் 2 plus. What is vanadium? Sir, 4s2 3d3. 3 plus என்ன அர்த்தம்? 3d2 sir. இது 3d3 சார். 3d3. ஓகேவா? இது half filled T2G பாருங்க. half filled T2G ஆர்பிட்டால பாருங்க. அதனால இதுக்கு வேல்யூ கம்மியா இருக்கு. இந்த பேராகிராஃப் ஒரே ஒரு திரும்ப சொல்றேன் பாருங்க. ஸ்காண்டியம் when coming from 3 plus to 2 plus ஸ்காண்டியம்க்கு தான் லோவஸ்ட் வேல்யூ, ஜிங்க்கு தான் ஹையஸ்ட் வேல்யூ ஏன்னு எக்ஸ்பிளைன் பண்ணிட்டேன். அதே மாதிரி மேங்கனீஸ்க்கு ஹை வேல்யூ, அயனுக்கு லோ வேல்யூ, வெனேடியத்துக்கும் லோ வேல்யூ ஏன்றது எல்லாமே எக்ஸ்பிளைன் பண்ணியாச்சு. கிளியர்? வாட் ஆர் வி கோயிங் டு see here sir? Right. Scandium, let me put that in a different way. Titanium, vanadium, chromium, manganese. So this is 3d2, 3d3, 3d5, 3d5. 4s1, 3d5 or something like that. Right. This is 4s2. So in the valence electron 4. So the maximum charge of titanium will be plus 4. Vanadium will be plus 5. Chromium will be plus 6. And manganese will be plus 7. The maximum charge will be plus 7. Maximum charge will be plus 7. But inge illiye sir, why the maximum charge plus 7 is not given here? It is a very 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 important thing. Why it is not given here? Right, look here, let me explain you. For an element, let the element be m, let a metal be m. ஒரு m னு ஒரு மெட்டல் இருக்குன்னு வெச்சுக்கோ. இது highest positive chargeல இருக்கணும்னா கூட நல்ல நெகட்டிவ் அதிகமா இருக்கிற ஒரு ஸ்பீஷீஸ் இருக்கணும். கரெக்டா? கரெக்டா? For the positive charge to be greater, we need a species whose negative charge is more. Correct? Sir, who will be best for this? Sir, halogens will be best for this. அப்படின்னு நாம நினைக்கிறோம். Because halogens are more electronegative. But halogens விட ஒருத்தன் இருக்கான். யாரு சார் அவனா? Oxygen will be the best for this purpose. In order to maintain a metal in its highest charge, oxygen is the best. Reason என்னன்னா ஒரே ஒரு முக்கியமான விஷயம் தான். Halogen cannot form multiple bond, but oxygen can form double bond. Oxygen can form double bond. So because of double bond forming ability, oxygen highly supports the species to hold them in their higher oxidation state. இப்போ இங்க பாரு, டைட்டானியம் பொறுத்த வரைக்கும் மேக்ஸிமம் சார்ஜ் +4 இருக்கலாம், வெனடியம் +5, குரோமியம் +6, ஓகே. பட் மேங்கனீஸ்க்கு +7 இல்லையா, அது நாட் பிரசன்ட் வித் ஹேலைட்ஸ். Mn plus 7 is not present with halides. It is present with oxygen. Why it is present with oxygen? Because oxygen can form double bonds, multiple bonds. சரி, அப்ப சரி Mn plus 7ல halogen கூட காம்பவுண்டே இல்லைன்னா இங்க இருக்கு பாரு, இதோ பாரு. This compound is known. Here the charge of manganese is +7. The charge of manganese is +7. Similarly, போக போக iron maximum charge +3, cobalt +3, nickel maximum charge is +2, copper maximum +2, zinc maximum +2. These are all given. These are all given. Okay, va? Right. Let me conclude the points here, pa. என்ன conclude பண்ண போறீங்க சார்? The ability of fluorine, how fluorine is stabilizing the highest oxidation state. Most important point. How fluorine is stabilizing the highest oxidation state na? Because it has higher lattice enthalpy. It has higher lattice enthalpy. ஓகேவா? ரைட். ஸோ இப்போ வெனடியம் +5 ஃப்ளூரினோட தான் சேருது. ஏன்னா லாட்டிஸ் எனர்ஜி ரொம்ப 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 அதிகம். ஸோ ஹாலஜன்ஸ் stabilize a compound because they have higher lattice energy. The ability of oxygen to stabilize the higher oxidation state. How oxygen stabilizes others? How oxygen stabilizes others na? By forming multiple bonds. By forming multiple bonds. So ரெண்டு விஷயம் தான் இங்க நான் சொல்ல வர்றது. ஒன்னு, how fluorine is stabilizing highest oxidation state of metal, and how oxygen is stabilizing highest oxidation state. Fluorine stabilizes because fluoride compounds have more lattice energy. Oxygen stabilizes because oxygen has more ability towards multiple bond formation. And who is better? Oxygen is better to maintain a metal in higher charge. ஒரு மெட்டலை ஹையர் சார்ஜ்ல வச்சிருக்கணும்னா ஆக்சிஜன் இஸ் த பெஸ்ட் ஃபெலோ. ஆர் ஏபிள் டு அண்டர்ஸ்டாண்ட் திஸ் பாயிண்ட்? ஓகே, கிளியர்?
Clear, sir.
ஓகே, இப்ப இங்க வாங்க. Sir, copper CuCl2, CuBr2, these are all stable. But the fellow CuI2 remember, CuI2, this fellow is highly unstable. This is highly unstable. Immediately, this fellow will become Cu2I2. That is what has been explained in the first two lines. இங்க இதைத்தான் explain பண்றாங்க. Why? Because what is the charge of copper here? Sir, the charge of copper is 2 plus, sir. What is the charge of I here? I minus 1, sir. This, what is the reduction potential of copper? Positive, plus 0.34. Positive, na the reaction உடனே நடக்கும். So, what happens na, this fellow is an electron acceptor. Electron acceptor. Electron acceptor means good oxidizing agent. So, copper 2 plus oxidizes I minus to iodine gas. இங்க தான் நடக்குது பாரு. Copper 2 plus I minus iodine gas oxidize பண்ணும். அப்ப copper 2 plus reduce ஆகணும் இல்லையா? That is why copper 2 plus will go to copper plus 1 charge. புரிஞ்சுதா? புரிஞ்சுதா? Copper 2 plus ஒரு நல்ல oxidizing agent. It oxidizes I minus to iodine gas and it gets reduced. It gets reduced. Copper 2 plus oxidizes I minus to iodine gas and it gets reduced. சரி, ஓகே. அடுத்தது என்ன சார்ஜ் ரெடியூஸ் ஆச்சு? சார், இட் கெட்ஸ் ரெடியூஸ்டு டு பிளஸ் 1 சார்ஜ், சார். ஓகே, சூப்பர். அடுத்த பாயிண்ட் பாரு. Copper plus 1 compounds are also unstable. Yeah, where? In aqueous solution. In solid state, they are stable. In aqueous solution, they are unstable. What they will do? They will undergo disproportionation. They will undergo disproportionation. That means it will go to a higher charge and also a lower charge. So, copper plus தன்னை விட அதிகமா இருக்கிற சார்ஜுக்கும் போகும், தன்னை விட கம்மியா இருக்கிற மெட்டாலிக் ஸ்டேட்டுக்கும் வரும். மெட்டாலிக் ஸ்டேட்டுக்கும் வரும். ஓகேவா? சரி, அடுத்த கேள்வி. போட போற ஸ்கிரீன் பார். Copper plus 4s0 3d10. Copper 2 plus 4s0 3d9. Tell me which is more stable. Answer my question. Among the two, which is more stable? Among the two, which is more stable?
Cu plus.
Right.
Cu
What you
plus.
expect is okay. Cu plus தான் stable இருக்கணும் நீ நினைக்கிறது okay. But actually this is stable. Why? Because when you dissolve these salts in water, when you dissolve this and this in water, ரெண்டையும் தண்ணியில கரைச்சினா, this fellow is more hydrated. தண்ணியில இருக்கிற OH மைனஸ்க்கு காப்பர் பிளஸ் விட 2 பிளஸ் தான் ரொம்ப பிடிக்கும். அது அவனுடைய நேச்சர். So because of more hydration, because of more negative hydration enthalpy of copper 2 plus, copper 2 plus is stable rather than copper plus. இந்த பாயிண்ட் புரியுதான்னு பாரு. இந்த இடம் ரொம்ப இம்பார்ட்டன்ட். Copper plus is stable or 2 plus stable or தண்ணியில in liquid state, copper 2 plus is more stable. Why? Because it has more hydration enthalpy. It has more hydration enthalpy. Clear? Okay, ma?
Yes, sir.
ஓகே சார். அப்புறம் இந்த பேராகிராஃப்ல என்ன சார் கொடுத்துருக்காங்க அப்படின்னாக்கா, இந்த ஆக்சைட்ஸ் கம்மிங் அப் ஆக்சைட்ஸை பத்தி தான். ஸோ எந்த ஒரு மெட்டலா வேணாலும் இருக்கட்டும், ரைட்டா, அது ஸ்டேபிளா இருக்கணும்னா ஹையர் சார்ஜ்ல இருக்கணும். ஹையர் சார்ஜ்ல இருக்கணும்னா ஆக்சிஜனால தான் முடியும். எக்ஸாம்பிள், ஸ்காண்டியத்தோட ஹையஸ்ட் சார்ஜ் +3, மேங்கனீஸோட ஹையஸ்ட் சார்ஜ் +7. ஸோ இந்த மாதிரி ஒவ்வொருத்தனும் தன்னுடைய ஹையஸ்ட் சார்ஜ்ல ஆக்சிஜன் கூட தான் சேர்றான். அயன் +3, மேக்சிமம் சார்ஜ் +3. ஓகேவா? ஸோ ஒரு எலமெண்ட் தன்னுடைய ஹையஸ்ட் சார்ஜ்ல இருக்கணும்னா ஆக்சிஜனோட தான் சேருது. இங்க பாரு, மேங்கனீஸ் ஃப்ளூரினோட சேராதா சார்னா சேருது. ஹையஸ்ட் சார்ஜ் ஃப்ளூரினோட +4 தான் மேங்கனீஸ்க்கு. மேங்கனீஸ்க்கு ஃப்ளூரினோட வாட் இஸ் த ஹையஸ்ட் சார்ஜ் ஆஃப் மேங்கனீஸ் வித் ஃப்ளூரின்? +4. Whereas with oxygen it is +7. Whereas with oxygen it is +7. ஓகேவா? அடுத்த பாயிண்ட், நெக்ஸ்ட் பாயிண்ட். In 11th standard chemical bonding, Fajon's rules. Since manganese is in highest charge, it will pull the electron cloud very, very effectively. This is called as polarization. This is called as polarization. If polarization is more na, then covalent character will also be more. This is called as Fajon's rules, which has been you studied in 11th standard chemical bonding topic. So polarization is more அப்படின்னும் போது more covalent character. So this compound is more covalent character. This compound is having more covalent character, and the two manganese present here, they are bonded to each other by a oxygen bridge. The two manganese present here are bonded together by oxygen bridge. புரிஞ்சுதா? Is it clear? Shall I go with the next one?
Yes, sir.
Super, sir. This tabular column tells you about the oxides of the 3D series elements, man. That's now I told you. Scandium, highest charge. It will exist with oxygen. Titanium, vanadium, chromium, manganese, iron. So whomsoever it may be, தன்னுடைய highest chargeல ஆக்சிஜனோட சேர்ந்து தான் அவன் ஸ்டேபிளா இருப்பான். Right. Now, what is the question asked? This is a very, very good oxidizing agent when comparing others. Why? 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 Because when comparing M and plus 7, M and plus 2 is more stable. More stable. So, stability of the lower species, this is the lower species. Stability of this lower species increases. Stability of this lower species increases. That is the reason given here. Okay, next. Chemical reactivity. சரி, நல்ல கவனி. ரியாக்டிவிட்டிக்கும் இந்த இஎம்எஃப்க்கும் நிறைய தொடர்பு. தட் இஸ் a lot of relation between reactivity with EMF. ஓகேவா? எக்ஸப்ட் காப்பர். Except copper, all other metals are comparatively reactive. With the exception of copper, except copper, all the metals are more reactive, and they will react with acid and release hydrogen gas. They will react with acid and they will release hydrogen gas. Okay, va? Next thing. Mn3 plus and cobalt 3 plus, they are very good oxidizing agents. How do you know, sir? How do you know, sir? Just now I told you Mn3 plus becoming Mn2 plus, cobalt 3 plus becoming cobalt 2 plus. This value, sir, this EMF is very, very high. சொன்னமா சொன்னமா EMF ரொம்ப ரொம்ப அதிகமா இருக்குன்னா this reaction will happen. That means Mn3 plus will accept an electron and it will become Mn2 plus. Cobalt 3 plus will accept an electron and it will become cobalt 2 plus. அதனால இந்த ரெண்டுமே ரொம்ப ரொம்ப பவர்ஃபுல்லான ஆக்சிடைசிங் ஏஜென்ட்ஸ். கொடுத்துருக்காங்களா பாரு, கொடுத்துருக்காங்களா பாரு. ஓகேவா? Then next point. These three are stronger reducing agents. Why? Because of their high reactivity, they will reduce H plus to hydrogen gas. They will reduce H plus to hydrogen gas. Okay, va? The remaining things given here is not that much important. You can go through them easily. We'll see the magnetic properties now. So, what are you coming to convey in case of magnetic properties, sir? ரொம்ப simple. What is diamagnetic and what is meant by paramagnetic? First சொல்லுங்க. Sir, diamagneticனா all the electrons are paired and it is repelled in magnetic field. Whereas paramagneticனா electrons, all the electrons சொல்ல முடியாது, unpaired electrons present. Unpaired electrons present. And paramagnetic substances are attracted in magnetic field. Paramagnetic substances are attracted in magnetic field. D block ஓட ஸ்பெஷாலிட்டி என்ன தெரியுமா? D blockல very very highly paramagnetic substance இருக்கு. Extremely paramagnetic substanceம் இருக்கு D blockல. And they are called as ferromagnetic substances. They are called as ferromagnetic substances. They are very strongly attracted towards the magnetic field. Very strongly attracted. ஓகேவா? இப்ப இந்த டேபுலர் காலத்தை பாருங்க. D0 as well as D10. Both of them will be having zero dipole moment. Zero unpaired electrons, so zero dipole moment. Zero unpaired electrons, so zero dipole moment. D1 and D9, both of them have one unpaired electron. Both of them have one unpaired electron. Similarly, D2 and D8, both of them have two unpaired electron. D3, D7, D4, D6, D5 is a different case. So in all the cases, you can easily calculate the number of unpaired electrons. From the unpaired electrons, you can calculate the magnetic moment. What is the formula? Mu equal to root of n into n plus 2. So these are the calculated values and these are the the observed values from the experiments. Observed value from the experiments. Okay, va? Check. And some questions may be asked from this part. They will give you some solution and atomic number 25, divalent ion. That means manganese plus 2. That is 3d5 configuration. So unpaired electrons n is equal to 5. So mu equal to root of 5 into 5 plus 2 Bohr magnetron. So root of 5 into 7. Root 35 bm. Bohr magnetron is the unit. Sir, if it is root 36 now, I will put 6 as the answer. Since it is root 35, 5.9 something will be the answer, sir. Like that you have to give. Okay, va? Now the next thing, formation of colored ions. D block elements la mostly they are forming colored ions. Why? Why? அப்படின்னா பாரு. The energy for excitation corresponds to the frequency of light absorbed. And this generally lies in what region, pa? Visible region. That is why most of the substances are colored, and the color we observe is the complementary color of the light absorbed, not the same light which the substance is absorbing. We are seeing the color of the complementary thing, complementary color of the substance, complementary color of the light absorbed. Okay, va? Example, let me put that in simple way. Color is complementary to the absorbed light. Complementary to the absorbed light. Point number one. Point number two. Color is determined by who is determining the color, sir? Na? Ligand. Ligand. Coordination compounds ஒரு lesson படிப்போம் அங்க நான் உங்களுக்கு டீடைலா சொல்லி தரேன். For example, if iron is bonding with water, six times in it will be having a different color. If iron is bonding with cyanide, it will be having a different color. So the color depends upon water or cyanide to whom the central metal is bonding with. Point number three. D0 and D10. Only these two are colorless. Only these two are colorless. Why? Because color is produced by DD transition. Sir, what is DD transition? You know, there are five d orbitals. What is the name of the five d orbitals? Are dxy, dyz, dxz, dx square minus y square, dz square. Yeah, you know this, right? And what is the specialty of these three? Sir, I know in 11th standard itself, these three orbitals have their lobes in between the axis. X axis க்கும் y axis க்கும் நடுவுல lobe இருக்கும் அந்த மாதிரி. Whereas these two they have lobes along the axis மேலேயே lobes இருக்கும். அதனால in presence of ligand the d orbital splits into two group, T2G group, EG group. These three are called as T2G and these two are called as EG. It will split. அப்படி split ஆகுதா? அதனால இங்க இருக்கிற ஒரு d எலக்ட்ரான் ஈஸியா இங்க போலாமா? இதத்தான் இந்த ஃபர்ஸ்ட் மூணு லைன்ல சொன்னோம். இந்த எக்ஸைட்டேஷனுக்கு தேவைப்படுற எனர்ஜி விசிபிள் ரீஜியன்லயே இருக்கு அப்படிங்கறது தான் அந்த பேராகிராஃப் சொல்லுது. And when the electron goes to the higher orbit, after some time it will come back. When coming back, it gives out the complementary color that we are seeing by our eyes as colored compounds. So, அப்ப கலருக்கு என்ன காரணம்? What is the reason for color? It is nothing but the DD transition. DD transition தான் கலருக்கு காரணம். So, here color of some ions are given. Some ions with their color is given. You just go through the paragraph, no need for you to mug up the thing. But anyway, you should know which is colored and which is colorless. So we know that we have five d orbitals and they are classified into T2G and EG. When bond formation happens, during bond formation, it splits into two groups, TG and EG. Like that, it splits. Now what happens? Sir, for an electron to go to a higher orbit requires more energy, but both these are d orbital. This is also d orbital and this is also d orbital. For this excitation, A very small amount of energy is required. Very small amount of energy is required. So it easily goes away. It easily goes away. And when coming back, and when the electron comes back, it releases energy that we are observing as color. We observe as color. புரிஞ்சுதா பாருங்க. ஓகேவா பாருங்க. Hereafter it is going to be a very interesting lesson only. Next. Sir, formation of complex compounds. What is a complex compound? Look at the screen. These are all the complex compounds. In the Madi compounds, the compounds like this are called as complex compounds. There is a separate lesson for this. Coordination compounds. This is the next lesson of D block. So coordination compounds ஒரு தனி lesson படிக்க போறோம் விட்டுரு. Just for your knowledge, I'm telling you. This is metal and this is ligand. Here, what happens, sir? Metal is acting as electron acceptor and ligand is electron donor. Metal is accepting electrons from ligands. Ma. Sir, why D blocks are forming very strong and good complexes for a compound to form complex? Conditions for complex formation. Ma. Let me put that in a simple way. Conditions for complex formation. Sir, what are the conditions to form complex like this? Point number one, the metal should be of small size and it should have a very high positive charge density. Very high positive charge density. Point number three, it should have empty d orbitals to accept the electrons. To this is the donor na, this is acceptor na. This acceptor must have empty orbitals to accept those electrons. Empty d orbitals to accept the electrons. All these three conditions are fully satisfied by d block. Fully satisfied by d block elements. That is why d block elements are forming a very large number of complex compounds. Very large number of complex compounds. புரிஞ்சுதா? Is it clear?
Yes,
Next,
sir.
next, catalytic property. Whenever you take a reaction, ma, in whatever the reaction, 99 percentage D block element will be the catalyst. எந்த reaction வேணாலும் நீ எடுத்துக்கோ. For example, you have studied Haber process. Nitrogen plus hydrogen combine to form ammonia. This is Haber process. யார் இந்த reactionல catalyst? Iron தான் catalyst. There is a secondary catalyst. Molybdenum தான் the secondary catalyst. These are both are D block elements. Both are D block elements. Sir, போன இதுல சொன்னீங்கல்ல conditions for formation of complex அதே மாதிரி சொல்லுங்க. What are the conditions for a substance to be a catalyst? Conditions for catalyst என்னென்ன? Point number one, ability to adopt different oxidation states. That is the main thing and that is the only thing. For example, manganese பாரு from zero state plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 up to plus 7 it can exist. It can exist. So if somebody is giving electron, plus 7 will accept electron and come to lower charge. Somebody needs electron, this fellow will give electron and it will go to higher charge. So depending upon the requirement of the reaction, some reaction may need electron, some reaction may give out electron. These fellows, since they are having different charges, depending upon the reaction, they will work and they will accept or donate electrons and thus they act as catalyst. And thus they act as catalyst. புரிஞ்சுதா? ஓகேவா? So look here. D block elements are having greater catalytic property. Why? Because one thing I told you, they can form variable different oxidation state. Another thing, the surface of the metal act as a thing where, for example, this is double bonded compound. Hydrogen adds to it and it becomes single bonded compound. How this happens? Na? This ethane, it will come and attach to the surface. Hydrogen will come and attach to the surface. In this surface alone, the reaction will happen and they get removed as product. So, D block elements provide free surface for the reaction to happen. Finally, empty d orbitals are present which supports the reaction. In the reaction, vanadium pentoxide is a catalyst. Vanadium is a D block element. Vanadium is a D block element. In the reaction, iron 3 plus is a catalyst, which is a D block element. Nickel is a catalyst, which is a D block element. So, in 99% of the reaction, D block elements are the alone who are acting as catalyst. புரிஞ்சுதா? ஓகேவா?
Yes, sir.
Yes. இதுல NCERT ல இந்த ரியாக்ஷன் கொடுத்திருக்காங்க. அந்த ரியாக்ஷன் நமக்கு தெரிஞ்சிருக்கணும். இங்க பாருங்க இந்த ரியாக்ஷன்ல அயன் 3 தான் கேட்டலிஸ்ட். This is the reaction. Iodide reacts with persulfate and it becomes sulfate. This is the reaction. How it happens? How it happens அப்படின்னா this fellow iron, he will first combine with this fellow and he will become iron 2 plus. Now this iron 2 plus will combine this fellow and finally the product is obtained. Now, if you add these two reaction, you will get this reaction. You will get this reaction. In this reaction, iron 3 plus is acting as catalyst. Iron 3 plus is acting as catalyst, and this is very, very important. Okay. Understood? Shall I go for the next one? Yes. Sir, what is next one, sir? Interstitial compounds. So through this diagram, you can easily understand what is an interstitial compound. Nothing. Look, all the white colored around, they refer nickel. No, they refer nickel. And this is nothing but hydrogen, which is trapped in between nickel. So interstitial compounds na என்ன அப்படின்னு சொல்றோம் பாரு. When hydrogen, boron, carbon, like small atoms, they are trapped in the spaces of D block elements. For example, this is all nickel. So nickel, in most of the reactions you might have seen, you will write nickel with hydrogen. This is a reducing agent. Why? Because nickel traps a lot of hydrogen within it. Such compounds are called as what compounds, pa? Interstitial compounds. And they are non-stoichiometric. Non-stoichiometric என்ன சார்? இப்ப நிக்கல் ஆக்சைடுனா எனக்கு ஃபார்முலா தெரியும் சார், NiO. நிக்கல் குளோரைட் தான் எனக்கு ஃபார்முலா தெரியும் சார், NiCl2. This is nickel hydride. I don't know the formula. This is not 1:1. I don't know how much hydrogen is there, whether it is greater or less, I don't know. See here, this is called as non-stoichiometric compound. They are not 100% ionic, not 100% covalent. They are harder than the pure nickel metal. Pure metal is hard, high melting point than the pure metal. So they are chemically inert than the pure metal. So they have all these points are advantages for the thing. So D block elements form a lot of interstitial compounds. I think now you are clear with what is an interstitial compound and what are the properties of an interstitial compound. Already NEET exam, they have asked a question like this. Which of the following does not correspond to the nature of interstitial compound? 3 points are given from this and 1 point is given away. Okay, va? So இதெல்லாம் properties of interstitial compounds that you should memorize. Clear? Next, alloy formation. D block elements are the ones which are forming a lot of alloys. For example, let me put it in a very different way. 100 years before, ironing the cloth is a very, very difficult thing. துணி அயன் பண்றது ரொம்ப ரொம்ப கஷ்டம். It is a very big process. But now ironing you can do just by switching on the iron box, because iron box contains nichrome, which is an alloy of nickel and chromium. As soon as the current passes through the coil, it gets heated up because of a lot of resistance. Resistance ரொம்ப அதிகம்ன்றதுனால இமீடியட்டா கரண்ட் பாஸ் ஆனோடனே இது சூடாயிடும். அண்ட் ஆல்சோ இட் வில் பி வெரி ஸ்மூத்தி. அதனால நம்ம ஃபேப்ரிக் அது எதுவுமே பண்ணாது. இட் இஸ் ஆல் பிகாஸ் ஆஃப் அன் அல்லாய். ஓகேவா? அதனால அல்லாய்ஸ் ரொம்ப ரொம்ப இம்பார்ட்டன்ட். இப்போ அல்லாய்ஸ்னா என்ன? ஹோமோஜீனியஸ் மிக்சர் ஆஃப் சாலிட்ஸ். லாட் ஆஃப் மெட்டல்ஸ் ஒன்னோட ஒன்னு மிக்ஸ் ஆகுது. த இம்பார்ட்டன்ட் திங் இஸ், sir, any metal can form alloy with any metal, or no? What is the reason, sir? Their radii should be within 15%. If the radii of metal A is 1, the radii of metal B should be between 0.85 to 1.15. In between this range, the radii should be there. 0.15 below or 0.15 above. Within 15%, the radii should be there. Then only they can form alloy. Okay, va? Just they will replace the atom. They will just sit in other elements position. Because of similarity in size, they can just substitute the atoms and sit in another one's place. So what happens is, sir, because of this, we have a lot of positive things. What are the positive things? Ability to do work increases, sir. For example, brass. Brass is an alloy of copper and zinc. Bronze. Bronze is an alloy of copper with tin. Likewise, a lot of alloys. For example, stainless steel. which we use as utensils. In all our kitchen utensils are stainless steel, which is an alloy, which is an alloy of copper, iron with carbon also to a small extent. Carbon also is used there. So these are all alloys which are useful to our day-to-day life. So these are the last three difficult things paragraph from which it is going to be next. பாருங்க sir, oxidation number increases. That means charge increases. Charge increases. Ionic character decreases. That means, let me put that in a different way. Oxidation state increases na, ionic character decreases. Ionic character decreases. That means covalent character increases. That means covalent character increases na, as soon as acidic character increases. Keep all these things in mind. They are all interrelated. நல்ல கவனி, acidic character is predominant, increases. புரிஞ்சுதா பாரு. So ionic character increases. Sorry, ionic character decreases. That means covalent character increases. This one is covalent green oil. This Mn2O7 is a covalent green oil. And acidic character also increases accordingly. Very important thing. Okay, va? Right. அடுத்தது Mn2O7. This is a covalent compound. It gives HMnO4, and H this fellow gives H2MnO4 and also H2Cr2O7. Whereas vanadium pentoxide is amphoteric. Pare, let me put that in a very different way. Pare, Mn2O7. This fellow is acidic. When treated with water, this fellow gives HMnO4. Similarly, CrO3, this is also acidic. When treated with water, it gives what? H2CrO4 and H2Cr2O7. H2CrO4 and H2Cr2O7. Vanadium pentoxide is amphoteric. Amphoteric na, it reacts with acid as well as base. Mainly acidic, it gives VO4 3 minus, VO4 3 minus, and VO2 plus salts. Oxocations. They are called as oxocations and oxoanions. Okay, ba? Right. What are the remaining things in this paragraph? Just you note down as points on the left hand side. Pa. That is enough. I'll give you. I've already noted down. I'll give you. What are the points, sir? Par. V2O3, V2O5, V2O5. Listen carefully. V2O4. Sorry, the second one is V2O4. This is V2O4. Okay. This is basic. This is less basic. This is amphoteric. And since it is a basic substance, when treated with acids, it produces VO2 plus ion. When treated with this amphoteric, na, it can be treated with acids as well as it can be treated with bases. With bases, it forms VO4 3 minus. With acids, it is forming VO4 plus. This is what has been given here. V2O reacts with alkali. Alkali means bases. With bases, it is giving this. With acids, it is giving this. Now, these things you have to mug up. There is no other go. There is no point in understanding these things. These things you have to mug up. அடுத்தது போலாமா? அடுத்தது இப்ப வெனடியம் பார்த்தோம் இல்லையா, குரோமியம் பாக்குறாங்க பாரு. CrO basic, Cr2O3, Cr2O3 amphoteric, CrO3 acidic. How do you know it is acidic, sir? Just now we have written CrO3 is acidic. பாருங்க அப்ப, what is the charge of chromium in the first compound? Sir, charge of chromium is +2, sir. Here charge of chromium is +3, sir. Here charge of chromium is +6. When the charge increases, that is oxidation state increases, acidic nature increases. That is what I told you a few minutes before. When oxidation state increases, acidic character increases. புரிஞ்சுதா? புரிஞ்சுதா?
Yes, sir.
வெரி குட் ராமா. அவ்வளவுதான்டா. இதுக்கு மேல இந்த லெசன் ரொம்ப ஈஸி ராமா. டோட்டலா நம்ம வேற ஒரு டைரக்ஷனுக்கு வரோம். இதுக்கு மேல இந்த லெசன்ல என்ன சார் அது? Now we are coming to the two compounds we are going to see. அப்பா இதுக்கு மேல தான் எனக்கே சந்தோஷமா இருக்கு. என்ன காம்பவுண்ட் சார் பார்க்க போறோம் அப்படின்னாக்கா potassium dichromate. What is the name of the compound? Potassium dichromate. Potassium dichromate. Right. This is a very important compound which is used in leather industry. Once this has been asked, pa, leather industry la use பண்ற salt எதுன்னு dichromate salt ன்னு ஆப்ஷன்ல கொடுத்துருமா. And it is a very important oxidizing agent. Oxidizing agent. சரி. First we are going to see the preparation. How we are preparing this potassium dichromate, and then we will see the chemical properties, physical properties, and all the things we'll see. Okay, va? Right. So now we are entering into the interesting part. இதுக்கு மேல இந்த lesson interesting இருக்கும். சந்தோஷப்பட்டுக்கோ எல்லாருமே. K2Cr2O7. This is potassium dichromate. Sir, வாங்க sir. Let's prepare. How to prepare potassium dichromate, sir? பாரு. The ore from which it is prepared is called as chromite ore. So பூமியில we have rocks called FeCr2O4. The rocks are called as chromite ore. So that they are taken to the industries and they are heated with basic medium. Heated na react with oxygen. Basic medium. Right. What happens? This chromite ore is converted into sodium chromate. Sodium chromate. This is a yellow solution. So next step. This sodium chromate is converted into sodium dichromate. This is orange crystals. Finally, this sodium dichromate is converted into potassium dichromate. This is orange red crystals. அவ்வளவுதான்ப்பா. This is the preparation chart. Shall I write the, all other reactants and products? Shall I write all other reactants and products? Come and tell me. எழுதலாமா?
Yes, sir.
Yes. பாரு இங்க வேற என்ன what are the byproducts? What are all the byproducts? See, carbon is not entered in the product side. So it goes out as carbon dioxide gas. Okay, well, next. Iron is not yet written on the right hand side. It is removed as iron oxide. Iron is removed as iron oxide. No need for you to mug up the memory and the balanced equation. Because when you go for this balancing equation, that will be very tedious process. 4, 8, 7, 8, 2, 8, like that number will come. No need for you to understand the reaction in a balanced way. Anyway, for board exam, you have to balance. Okay, board exam, you balance பண்ணி தான் ஆகணும். So in the case of NEET or JW preparation, no need for you to mug up. அதுக்கு நான் ஒரு hint தரேன். You just remember this is 8 and this is 7. Then it will be easy for you to do all the balancing. Okay, I just remember this is 8 and this is 7. Now you can balance the remaining things. Okay, I'll go for the next reaction. Pa. Look at the next reaction. Sir, how to convert chromate into dichromate? How to convert chromate into dichromate? The reagent used for this purpose is nothing but our best reagent, sulfuric acid. Sulfuric acid. So he will convert chromate into dichromate. And what are the products removed? Hydrogen is removed as water. And sulfate is removed as sodium sulfate. Sodium sulfate. Finally, sir, we have prepared sodium dichromate. Why we are converting it into potassium dichromate? Na? Listen, pa, this is a soluble compound. This is dissolved state, liquid state la இருக்கும். Whereas this fellow is insoluble fellow. That he is not that much soluble. அல்லது solubility is less அப்படின்னு சொல்லலாம். Solubility is less. That is why we are converting the sodium dichromate into potassium dichromate. What is the reagent used for this? Nothing but KCl. So what is the another product? NaCl. இப்ப புரிஞ்சதா பாரு. You can write this reaction now even for board exam. Okay, va? So we have prepared this potassium dichromate salt which is shown in the screen. பாரு. NCERT ல கொடுத்திருக்காங்க, right? Then what are we understanding? Reaction step number 2. What is step number 2? Sir, chromate when treated with acid becomes dichromate. Sir, the same step is given here, sir. The same step is given here, sir. Chromate, when treated with acid, becomes dichromate. புரிஞ்சுதா? Right. Reverse. Dichromate, when treated with base, becomes chromate. பாரு, chromate with acid na dichromate. Dichromate with base na chromate. Are you able to understand the reverse reactions? Okay, clear? Right. Chromate CrO4 2 minus. Dichromate Cr2O7 2 minus. These are the structures drawn. So here chromium has 6 valence electrons. Chromium has 6 valence electrons. One here, two, three, four. The fifth one and இல்ல இல்ல nothing correct தான் என்னன்னா chromium is existing in plus 6 charge so it is completely filled inert gas configuration இல்லையா it is present as tetrahedral structures both of them are tetrahedral structures and the bond angle is given the bond angle bond length you have to mug up no other go just you have to mug up compulsorily புரிஞ்சுதா அடுத்தது போலாமா ஓகேவா ரைட் நெக்ஸ்ட் both of them are very strong oxidizing agent whether it is sodium dichromate or it is potassium dichromate both of them are very strong oxidizing agents okay va and potassium dichromate this K2Cr2O7 underline this point it is used as primary standard what is meant by primary standard sir primary standard na this is used as reference to strength to calculate the strength of others if suppose you are having um, oxalic acid solution வச்சுக்கோ you want to know what is the concentration of oxalic acid you can use this fellow to determine the concentration of oxalic acid okay va it is called as primary standard because this fellow's concentration will not change with time okay பாரு நாம என்ன சொல்றோம் Cr2O7 2 minus dichromate ion is an oxidizing agent ன்னு சொல்றோம் it oxidizes others it gets reduced to chromium 3 plus chromium 3 plus it oxidizes others and from 6 plus it goes to 3 plus state now I am going to balance this reaction 11th standard redox reaction topic பாரு plus 6 ல இருந்து plus 3 state க்கு போகுது how many electron difference how many electron difference how many electron difference 3 electron for 1 chromium here actually there are 2 chromium so 2 into 3 that means 6 electron difference புரிஞ்சுதா so we have to add the 6 electrons to the side where the charge is more. Now, sir, 2 chromium balance. There are 7 oxygen in the left side. So I have to add 7 water molecules to the right side. Now there are 14 hydrogens on the right side. So I have to add 14 H plus to the left. This is this equation. புரிஞ்சுதா பாருங்க. Come on, answer my question. Okay, wow.
Yes, sir.
Yes. And the EMF of this reaction is positive. EMF positive na the reaction spontaneous ன்னு அர்த்தம். This reaction is ready to happen ன்னு அர்த்தம். Ready to happen அப்படின்னு அர்த்தம். Sir, you just now told K2Cr2O7 is a oxidizing agent. It oxidizes others and it becomes 3 plus. 6 electron is the difference. Balancing 2. 7 water molecules to the right. That means 14 H plus to the left. Okay. பாரு எப்படி எழுதுறதுன்னு சொல்லித்தரேன் சார் இது யார பேலன்ஸ் பண்ணுது சார் சல்ஃபர் ஃப்ரம் -2 இஸ் கன்வெர்டட் இன்டு சல்ஃபர் ஜீரோ ஸ்டேட் புரிஞ்சுதா சரி sulfur from -2 state is converted into sulfur. What is the difference in electron? 2 electron. இந்த பக்கம் தான் ஆட் பண்ணணும் ஏன்னா இந்த பக்கம் தான் சார்ஜ் அதிகம் ஓகேவா புரிஞ்சுதா அந்த பாயிண்ட் இது எல்லாருக்கும் புரிஞ்சுதா ஓகே சூப்பர் நான் ரெண்டையும் ஆட் பண்ணணும்னு வச்சுக்கோயேன் ஈக்குவல் நம்பர் ஆஃப் எலக்ட்ரான்ஸ் இருக்கணும் இங்க 6 எலக்ட்ரான் இருந்தா இங்க 6 இருக்கணும் அப்ப நான் என்ன பண்றேன் இந்த ஈக்குவேஷனை 3 ஆல மல்டிப்ளை பண்ணிக்கிறேன் 3 3 it will become now 6 electrons now if I add 6 and 6 gets cancelled so what is the final equation Cr2O7 2 minus plus 3 sulfide plus 14 H plus gives 3 sulfur plus 2 chromium 3 plus plus 7H2O. This is the final balanced equation. So look at the screen carefully, pa. He is an oxidizing agent. He will oxidize others, and from this state he will become this state. Purinjira. After oxidation, this will become this. Purinjira. Okay, va. Okay, va. Whereas this is oxidized to this. So, paranga, I have written an equation here, right? I will show you the reaction in this diagram. I will show you the reaction in this diagram. This is the reaction. Purinjida par. This and this combined to give this. Purinjida. Is it clear? Yes, sir. So what are the other substances that are oxidized? Sulfur dioxide is oxidized to sulfate ion. Nitrite ion is oxidized to nitrate ion. Sulfite is oxidized to sulfate ion. Tin 2 plus is oxidized to tin 4 plus. Iron 2 plus is oxidized to iron 3 plus. Br minus is oxidized to bromine. I minus is oxidized to iodine. Alcohol is oxidized to carboxylic acid. So these are all the oxidation reactions. If you want me to write now, I'm ready to write. Yeah, now I'll write the equation for iodine. Sir, dichromate is a very good oxidizing agent. It becomes chromium 3 plus, sir, 2 molecules, sir, 6 electrons, sir, 7 water molecules, sir, 14 H plus, sir. The 6 electron in the bottom, sorry. Okay. Now I minus is converted into I2. First balance it. Sir, here it is minus 1, here it is 0. The shift in electron is 1 electron for 1 iodine, but there are actually 2 particles. So totally 2 electron. I have to add the 2 electron to the side where the charge is more. For a left side, the charge is minus 1. Right side, the charge is 0. Where the charge is more? Left side or right side? Right side. So I have to add the 2 electrons to the right side. Very good, ma. 2 electrons to the right side. When I'm going to add both the reactions, 6 electrons must be balanced. So multiply this by 3. Sir, up 6I2, I minus, sorry, 6I minus 3I2, 6 electron. Now you add, sir. Now cancel these two. I'll get the final equation easily. What is the final equation? Cr272 minus 6I minus 14H plus 2 chromium 3 plus 7 water molecules 3 iodine. This is the final answer. Clear for everybody?